Hi guys, it's Mrs. Perno here. I am going to do a mini lesson on sedimentary rocks. So I just want to give you a brief overview of this week. So today, Monday, you will look and learn about sedimentary rocks. Then on Tuesday, let me just pull up the calendar for you guys so you can see as I'm talking. So then on Tuesday, you're going to do the virtual sedimentary rock lab, which I will then link. So you'll see a link that you will right here click on. Actually, no, I'm lying. So I'm sorry. So Monday you'll do sedimentary rock lesson. On Tuesday we'll meet for Google Meets to go over questions, and you could just check your answers. So Tuesday will be a very light day of work. Wednesday will be your sedimentary rock lab. I'm glad I'm checking this as I'm going over it with you. A virtual rock lab, and that won't be due to the following week. And then Thursday will be your checkpoint for sedimentary rocks. Also, get your igneous rocks in. Please make sure you are checking the calendar, or I'm not, you're checking the calendar always, but make sure you're checking the lab sheet that I've linked to Classroom. Lab sheet shows me who's turned in what lab, and I want to give props to Lindsay, Sophie, Anna, and Serena, who've already turned in their igneous rock labs already. And Gowanna kicked butt last week with turning work in on time, and I didn't really have to chase down too many Gowanna kids to get their work in. So let's step it up, Acadia. I mean, Coda, there's only two of you, so you guys always rock. No pun intended. So let's get started with igneous rocks. So you will do the lesson, and then you're going to click on the links and you're going to read it, and then you're going to watch my video on me teaching it. So I have, where is it? Where's my reference table? Sorry, I'm a little slow tonight. Hope you guys had a good weekend. Did a lot of yard work, cleaning up the yard and getting outside and cleaning up the garage. So now I'm making a video at Sunday night for you guys. And we're going to look at the reference table. So this is, I believe, page 7. And the scheme for identifying sedimentary rocks. You're going to notice we have 3 types of igneous rocks. We have clastic, which means fragmental, which means fragments deposited from rivers. From here, rivers depositing sediment over time have been compacted, compressed together, sometimes cemented together to turn into rocks. So you can see as the river's depositing, layers get formed, and this doesn't happen overnight, and this doesn't happen within like months. It takes like millions of years to make these layers of sedimentary rocks, and they usually happen underneath water when the river's deposited into oceans, and the water is the supplies the pressure to form these igneous rocks. Now I'm using my hands and you guys can't see that, so I'm just laughing at myself as I am making these notes. All right, so we're back. So our clastic rocks, they are classified by grain size. All right, so our smallest particles, clay, right? So just like we did in our deposition unit, so anything less than 0.0004 centimeters, when those sediments are compacted, they form shale. So clay forms shale. Silt would be your next largest sediment. As that's deposited, it makes siltstone. Next largest particle would be sand, and sand would make sandstone. Now, there is no such thing as pebble or cobblestone. So anything larger would be in the form or in the category of breccia or conglomerate. Now, the difference between breccia and conglomerate is breccia has more angular fragments and conglomerate has more rounder fragments. And I did have some pictures up here to show you. So you could see, just had some examples. So see, this is conglomerate. This picture right here, you've got rounded fragments that have been literally cemented together. Same cement in cement trucks, but it's calcite that cements these rocks together. Breccia, I did have an example up here, would be more angular particles that are cemented together. So maybe those particles didn't go through erosion and extensive erosion as much as the conglomerate did. So here's the picture here I wanted to show you. The breccia has more angular, jagged pieces that have been cemented together. Okay, so that would be your clastic rocks. Then, oh, and notice it's inorganic because they were never once living, and they were made on land derived, either underwater still, that's still land, or literally on the shore, the sandstone on the shore of the continental crust. Then we have two other types, chemical or organically formed sedimentary rocks. Now, our chemical is called crystalline because they're made of mineral crystals. For example, halite is your salt mineral, gypsum, a very soft white mineral as well, and dolomite. So what happens was, about the time of Pangaea, about 250 million years ago, the United States was once covered by a warm, shallow sea. And when that sea evaporated, these minerals fell out, which we say precipitated out of water as the water was evaporating, and clumped together. So what I wanted to show you in class was the water from the Saratoga waters that I was the springs, that's the word I was looking for. The springs, I was going to leave water out overnight, and you were going to see that the water would evaporate, but these crystals would fall out, precipitate out of the water, and form really cool shapes along the bottom of the petri dish, but I didn't get a chance to do that. But you can make your own crystals too, because rock salt is very much like rock candy. So rock candy is crystals of sugar where you saturate water with sugar, hot water, and you put a string in the water, and you put something heavy on the string so the string stays tight, and the water evaporates, and over time you form these rock crystals, the sugar crystals, which is rock candy. So that's how those form. And notice they're only made of one mineral. So dolomite makes dolostone, gypsum makes rock gypsum, and talite makes rock salt. Limestone, we will come back to limestone. Bioclastic, meaning they once had living organisms or living material. So coal is actually made with plant remains, and over time the plant remains get pushed down and compressed, and they form coal. So that's why coal is very easily burnt. And during the time when the United States was once a warm, shallow sea, we were by the equator, and a lot of these plants got compacted, and that's why Pennsylvania has large coal mines. Now, limestone can be two different. Limestone could be crystalline. So that's when calcite will, water will evaporate and leave calcite behind to form limestone. That's why limestone reacts with acid rain and acid because of calcite. Or limestone can also be bioclastic, so pieces of shells that get clumped together to form this rock, which we call fossiliferous limestone, or its technical name is coquina. And I will show you some pictures of that. So also wanted to show you that you'll notice that a lot of sedimentary rocks have these layers because, like I said, the sediments get deposited into like a lake, and over time the water compresses, and it just shows the depositional events that took place. Like this layer right here had darker sand, and then lighter sand, then darker sand. So you're seeing these layers of sediments. So we say a lot of the times that sedimentary rocks often form in layers, very cool layers that you're seeing. Again, layers in these sedimentary rocks. Now, remember how I said igneous rocks are the majority of the Earth's crust. However, we do have this very thin veneer. So a veneer means a layer of sedimentary rocks that cover the United States, because all rocks can be weathered into sediments, and sediments can be formed into sedimentary rocks. So the major ways to form sedimentary rocks are by compaction, which is that overlying pressure from water or other rock layers, cementation, cementing the rocks together, evaporation or precipitation, where the water evaporates and precipitates out the mineral, or by your biological means. So I want to show you coquina because it's pretty cool. Coquina. And it'd be really cooler in class if I was able to show you this, but you're seeing all these shells that have been broken off, and we'd probably find this more at a marine place, broken off and glued together. I call this seagull throw up. It looks like when a seagull throws up, it just throws up all these shells because it tries to eat the shell and its body can't digest it, so it throws it back up. Or otherwise known as the granola rock. But technical name is coquina, which is fossiliferous limestone. It will react with acid because calcite is the glue that glues these sediments together. So before I end, I just want to go over one more thing with you. We'll go over, here's this sedimentary rocks lesson. I do miss you guys a lot. I really don't like teaching 4th grade. All right, so you'll fill in these notes based on what I just told you. You'll go through the slides too to help you. I went over mostly all of this with you. Oh, here we go. This is why I wanted to look at the notes. Sedimentary rocks are the only rocks that contain fossils. If you remember from 6th grade, fossils are imprints of organisms, not the organism itself. It's an imprint. So if you think about it, igneous rocks, the magma or the lava would disintegrate that fossil and you wouldn't have any remnants of it. And metamorphic rocks, we haven't got there yet, but metamorphic rocks, too much heat and pressure would deform the fossil. So the only types of rocks we can get sedimentary rocks on in fossils are in sedimentary rocks. Usually shale and limestone, you'll have a lot of fossils in them. We went through this. And just another thing, you will have sediments. The way you make a sedimentary rock is you have to have sediments. And how do we form sediments? Sediments are formed by weather and erosion. So we get sediments that form, they have to then be deposited, and then they'll go through compaction, cementation, or the precipitation out of evaporation of water and precipitate out of the minerals. So that is my lesson to you guys. Go over it, look it over, listen to me, stop, rewind, go back, whatever you need to do to be successful. But please make sure you're staying on the schedule. If you don't, it gets a little overwhelming. And on Tuesday, please come with questions. I will do another brief overview of the sedimentary rocks, but please come with questions. We won't get into metamorphic rocks until after April 20th. So next week I have some just kind of review stuff to do. Nothing too heavy, not a lot. So just try and get your work done this week. Next week will be quote unquote light work. And then when we get back, we'll do the metamorphic rocks. So I will do a Google Meets on Tuesday. I'm not sure if we'll need to do one later on in the week, but I'll check in with you guys. Maybe we'll do a quick one on Thursday. That is it for me, guys. I am going to watch some TV and then head to bed. Hope you have a great week. I am missing you all, and I hope you are well. And I hope to see you very soon. Goodbye.